Hello, I'm Hugh Manfield and welcome back to the lectures on fluid space theory. Now today we're going to actually start digging into fluid space theory and get to the heart of the subject. I will explain the breakthrough idea that makes fluid space theory work and how that changes everything. Now if you want to know more, you can always pick up a copy of my book, Einstein and Aliens, and all the math is worked out in the appendices. And there's a nice science fiction adventure that explains everything if you don't want to read the appendices and work through the math. So, at the end of the last lecture, we were left with the somewhat perplexing conclusion that space-time must be falling through the surface of the Earth from all directions at once. Now this sounds like an impossible thing. It sounds like a crazy idea. It sounds like an idea that people should just walk away from and give up on. Well, I'm stubborn. And I stuck to it, and I've come up with the reason that this could actually happen. To understand how this happens, we have to think about funnel flow. So in this slide we have 4 pipes. Each of them have a taper section. Each section gets smaller. So basically we have fluid coming into the pipe at the same velocity. So as it travels down the pipe, the velocity stays the same. When it enters the tapered section, the velocity accelerates and it comes out at a higher speed. And the smaller the opening, the higher the speed it will come out. So the acceleration is all going on in the tapered section. So that's where all the interesting stuff happens, and that's where the acceleration field exists. So if we take a closer look at a funnel, we can see that if we have velocity going in over the area, and if the fluid is incompressible, that's going to equal the velocity coming out times the area of the exit. So it's a pretty simple equation, and we can chart what those velocities would be. So let's say that the fluid is entering the funnel at 1 meter per second. So how fast does it come out if the exit is 1,000,000 times smaller? It comes out 1,000,000 times faster. So what if the exit is 300 million times smaller? Well, then it's going to come out at 300 million meters per second. And that's an interesting number because that's the speed of light. So in that case, we're going to have to account for relativity within the flow field. And that's what we do when we look at the flow. And we can see that the interesting stuff begins to happen at the narrow end. Accelerations are low out here, but they increasingly get bigger as we move toward the tip. You can see you go from 100 times faster to 1,000 times faster in less distance than it took to go from 2 times faster to 3 times faster. What we see here is Ricky is flying past in her ship, and she's tracking along at the same velocity as the fluid in the funnel. So as she gets faster and faster, her ship becomes length contracted and time dilated. So we would understand that the same thing would be happening within the flow field. When you get down near the tip, the fluid in the funnel is going to start to become length contracted in the direction of motion and time dilated. So what does that mean? Well, if we look at the funnel flow, it's going to be an acceleration field. And if we imagine that fluid to be space-time, then that means it's going to be a gravity field. So we could actually hang a clock on a string into the funnel and it would dangle straight down because that's the acceleration vector, that's the action of the gravitational field. Now some other things will be going on because the lower we drop it into the field, the stronger the gravity will get because the acceleration is increasing as you get closer to the tip. So this is just like a gravity field around a massive body. It has the same behavior. It's weak at a distance, and it's really strong when you get close to the center. Another thing that's going to happen is that as the clock is lowered deeper and deeper into the field, it's going to become length contracted and time dilated because it's immersed in the fluid that is length contracted and time dilated. It's going to behave according to what's going on in its local space. So you will have length contraction and time dilation you'll have a gravity field that increases in strength the closer you get to the center. Basically, a funnel flow analysis, applying relativity, gives you everything that is predicted in a gravity field that Einstein developed under general relativity. In this case, it's a lot easier to understand what's going on because we can imagine the fluid flow and get a gut level feel for how it's accelerating, how it's creating gravity, and how it's creating length contraction and time dilation. Gravity can be understood as a flow of fluid of space-time down a funnel. So now let's think a little bit more about what's actually going on in the funnel. If we have a massive object like a dead stellar core or neutron star or something, and we map out a cone of space that's leading toward the center of that object, that cone, the space will become length contracted and time dilated. Now if we could take that cone of space, move it out away from the object into free space where it could expand back out to its full length, what we would see is that it's not a straight-sided cone, it's actually a curved cone. It's a hyperbolic cone. So what does that mean? That means that the actual shape from the point of view inside the funnel is a hyperbolic funnel, while what we see when we look at it is we see a straight-sided funnel. But in reality, this green funnel is length contracted down and will fit inside the blue funnel. So to show that a little bit more clearly, I developed this chart where the yellow section represents the straight-sided funnel and the blue section represents the hyperbolic funnel. Now remember, both of these things are going on within the same space. The yellow section is what we imagine to be there when we look at it, but the blue section is what's actually going on if we were inside the flow field itself. This yellow cone would have a finite volume. We could calculate that volume. We can say, all right, that's how much space would fit inside that cone. But the blue hyperbolic cone has infinite volume. Once it becomes tangent, when the flow reaches the speed of light, this thin pipe section can go on in a straight pipe forever. And basically, all of the blue section is length contracted down and it fits inside what we see around the massive object, inside the yellow cone, but in reality, it's an infinite cone. So down at the heart, if we're talking about a black hole, down at the event horizon, at the heart of the field, space-time actually goes through a transition to where it becomes infinitely long in the direction leading inward, and yet you never get past the event horizon. So some of you viewers out there may be saying, yeah, this is all great, but what about Newton's first law? You said yourself that space can move through objects without resistance, and objects move through space without resistance. So what are you going to build your funnel from? Well, there's only one substance in the universe that can funnel space-time, and that substance is space-time itself. Now there's one thing that most people don't think about, but a sphere is actually a form of a cone. If we start packing cones around a sphere, all pointed at the center, we can pack in more and more of them until eventually we end up with a sphere of cones. And then at that point, if we have the flow field going on, we can take away the walls and the flow will funnel itself. Basically, we have sink flow in a spherical form, and the space-time has no choice but the funnel itself, just as if it's going down a single funnel. So I use this chart to explain a little bit more about what's going on with fluid space theory. You can imagine unit cubes. Let's say they're all 1 meter on a side, or maybe 1 kilometer on a side, or whatever size you want to make them. It doesn't matter. They're all falling down into a black hole, and the black hole is big enough to pull them in. So if we start out at infinity, the cube is going to measure 1 meter on each side. And as it falls inward, it's going to fall inward at escape velocity, because that's the rate that objects fall in free fall if released above a gravitating body out in space. they would fall inward at escape velocity. And that escape velocity increases and increases with the radius until down at the event horizon it reaches the speed of light. So these unit cubes keep getting length contracted and time dilated until they're time dilated to infinitely long seconds and zero length in the radial direction, and you have the formation of an event horizon. And that's really the heart of fluid space theory. It's a new idea of how space-time can infinitely flow into a gravitating body without the body getting full or the flow stopping. So that's basically the breakthrough idea of fluid space theory. How objects can continuously fall into a black hole, and the black hole, the funnel, basically makes room for more and more space as it falls in. The space-time has rearranged itself to allow for an infinite volume of inflowing space. So now you know how gravity is actually a sink flow of space-time into an object with relativity applied. And this form of motion, this sink flow, is really at the heart of every particle of matter in the universe. So now that you know that, you're ready to enter the world to a greater understanding of the cosmos. Keep watching and you'll learn about subjects like the old news aberration, how space and galaxies might actually be contracting. And then you'll find out what dark matter actually is, what's really inside a black hole, how antimatter is different from matter, and there's a fundamental way that is explained by fluid space theory. And fluid space theory can even tell us more about the expanding cosmos. Until next time, I'm Hugh Manfield.